Hello everyone, myself Rupam Das, Assistant Professor of Asansol Engineering College in Electronics and Communication Engineering Department. Name of the subject is Signals and System. Learning outcomes are at the end of the session, student will be able to understand convolution and circular convolution. Contents are circular convolution method, first definition, then classification of circular convolution, that is graphical method, tabular method and matrix method. Reference books are for this particular subject. The books are, first book is Signals and System by Anand Kumar, second book is Signals and System by Tarun Kumar Rawat, third book is Signals and System by Ramesh Babu, and fourth book is Signals and System by Nagor Kani. Definition of circular convolution. The circular convolution of two periodic discrete time sequence x1n and x2n with periodicity of n samples is defined as x3n equals to summation of m equal to 0 to capital N minus 1 x1m x2n minus m circular convolution of n, or x3n equal to summation of m equal to 0 to capital N minus 1 x2m multiplied by x1 n minus m circular convolution, where x3n is the sequence obtained by circular convolution, x1 n minus m double bracket of n represents the circular shifting of x1n, x2 double bracket under n minus of n represents circular shifting of x2n, and here m is the dummy variable. The output sequence x3n is obtained by circular convolution is also a periodic sequence with periodicity of n samples. Hence, this convolution is also called periodic convolution. The convolution relation can be symbolically expressed as x3n equal to x1n circular convolution of x2n equal to x2n circular convolution of x1n, where the symbol, the star encircled, indicates circular convolution or operation. Methods for circular convolution, there are lots of methods are there. Number one, graphical method. The circular convolution can be done graphically. Next is tabular method. Circular convolution can be done by the use of tabular method. Third is matrix method. Through the matrix formation, we have to form one matrix, and depending on that, the circular convolution can be done. We are going to see these three methods through one example so that it can be easily realizable. Now, for understanding of these three methods with the help of same problem, I am going to take one example. Question is, perform circular convolution of the two sequences x1n equal to 2, 1, 2, 1 and x2n equal to 1, 2, 3, 4. Here arrowhead indicates the initial position of x1n and this arrowhead indicates the initial position for x2n. Now to do this, the circular convolution of x1n and x2n is given by x3n equal to summation of m equal to 0 to capital N minus 1 x1m x2n minus m of n, that is equal to m is equal to 0 to capital N minus 1 x1m x2 comma n of m, where x2 comma n of m is equal to x2 n minus m, and here m is the dummy variable used for convolution. Next, whatever the sequence is given to you, the depending on that particular sequence, we have to represent this thing graphically. Now if I'm going to represent graphically x1n, so first we have to create one circle, and depending on that we are going to use this notation x1 of 0, x1 of 1, x1 of 2 and x1 of 3. So it's according to its position of 0, 1, 2, 3, each and every position it has its value. So x1 of 0 it have the value of 2, then 1, then 2, then 3. So this is the representation how you are going to represent this x1 of m. Similarly, x2 of m can be represented as x2 of 3, x2 of 0, x2 of 1 and x2 of 3. So as per that your position value can be written like this: 1, 2, 3 and 4. After that, you have to represent the total sequence according per the formula. You have to flip it. So that's why x2 of minus m can be represented like this: x2 of 0, then x2 of 3, then x2 of 2, then x2 of 1. And as per the position value, you have to put its corresponding value. Now, according to the circular convolution, we have to evaluate for n equal to 0 samples. So we have to write down the formula: x3 of 0 equal to m equal to 0 to 3, x1 of m, x2 of minus m, that is equal to summation of m equal to 0 to 3, x1 of m, x2 comma 0 of m. So basically, whatever the sequence we have evaluated previously for x1m and x2m, you have to write down. Then you have to multiply it as per this formula. You have to multiply it as per according to the position value, and finally you have to add it. So if I'm going to multiply these two circles, so it is coming 2 multiplied by 1, then 4 multiplied by 1, then 2 multiplied by 3, then 1 multiplied by 2. The multiplied output is written over here, and after multiplication it is coming 2, 4, 6 and 2. And if I'm going to add all the sequences, so it is coming 14. Similarly, we are going to evaluate at the position value n equal to 1. So we can write down 2, 1, 2, 1, x1m, there should not be any changes. But if we are going to see for x2 of m, so it can be represented like this. So we have to shift the total circle by one position. That means 1 is shifted to 4, 4 is shifted to 3, 3 is shifted to 2, and 2 is shifted to 1, like in that manner. So we can express x2 of m like in this format. Then you have to multiply, that is 1 into 1, then 2 into 4, then 1 into 3, and this 2 into 2. So like in that manner you have to represent the total circle. And after that, after evaluation of this, you have to add all the sequences. So 4 plus 1 plus 8 plus 3, so total it is coming 16. This is the evaluation for n equal to 1 samples. After that, we are going to evaluate x2 of n. Previously, whatever the sequence you have obtained, now the circle is again shifted in that manner. Previously 2 is situated over here, and 3 is situated over here, 4 is situated over here. We have to shift the sequence like in the in this anti-clockwise direction. And after that, you have to multiply as per the position value. So that means 2 multiplied by 1, then 2 multiplied by 1, 2 multiplied by 3, then 1 multiplied by 4. So the multiplied sequence has been shown over here in this particular cycle. Then you have to add all the sequences. That means 6 plus 2 plus 2 plus 4, so it is coming total 14. And after that, for n equal to 3, so you have to represent the total thing. Again it is to be shifted. That means 3 is shifted to 2, then 2 is shifted to 1, 1 is shifted to 4, and 4 is shifted to 3, like in that manner. Then on, you have to multiply it by x1m and x2m. Once you are going to multiply it, so it is coming 1 multiplied by 3, 2 multiplied by 2, 2 multiplied by 4, 1 multiplied by 1. So like in that manner you have to arrange the total sequences. Then you have to add, that is 8 plus 3 plus 4 plus 1. So added sequence is written over here, that is 16. And finally, for n equal to 0, n equal to 1, n equal to 2 and n equal to 3, you have the corresponding values. And whatever the values you are having, so that means you are getting this particular result, that is 14. Then for this case it is 8, that is 16. All the sequences are, you have to write in this particular field it over here, and indicate the position where the sequence is going to be started. So in this way you are going to represent the total thing. So this is one type of solution how you are going to get it. After that, we are going to see another method, that is circular convolution by the use of tabular method. So for doing this, you have to make one table. So this is particular table where you are going to first represent the m stands for this particular position value. According to position value you have to write down. Then x1 m is been written it over here. Then x2 of m it should be written over here. Then on x2, as per the position value you have to write. For position value 0, for position value 1, for position value 2, and for position value 3, you have to write down the total sequence for x1m. Similarly, for x2m you have to write down. Then x of minus m, as per the value, you have to use this for n equal to 0. If I'm going to put n is equal to 0 in this particular formula, here you can see x2 of minus m can be evaluated. So simply we have to flip the total sequence like in this manner, 4 3 2 1, then 4 3 2, like in this manner. Then whenever n is equal to sample value is equal to 1, then on you have to shift the position to from right side to left side by one position, like in this manner. Similarly, when it is position value is 2, so then on you have to shift the total sequence in the by the help of 2 position value. When it is 3, so when it is going to be 3, so it is going to be shifted from left side to right side 3 line, like in this manner, and you are getting this particular result. So in this way you are going to obtain the total table like in this manner. Now by using this particular formula, you can use this particular formula and you are going to obtain the total result. Now in this case you have to going to use whatever the formula you have evaluated. Now as per the position value, you are going to write for n is equal to 0 sample, for n is equal to 1 number of sample, for n is equal to 2 sample, and for n is equal to 3 sample. As per the position value, these are the position value. For position value 0, for position value 1, for position value 2, for position value 3, you are going to write down the value, multiply it, and finally the result here coming, this would be the result, that is 14 for n equal to 0, then 16 for n is equal to 1, then 14 again for n equal to 2, then it is coming n is equal to 3, that is 16. Now all the values are jotted down over here in this particular sequence, and you are getting the final result like in this manner. So this is the way how you are going to obtain the total result like this. Next we are going to see another method. This is method number 3. Name is circular convolution using matrices. This is the point I am going to highlight, that is the matrices you are going to use this. For going to do this, you are going to represent the total sequence like this. Second sequence is written x0 x2 x2 of 1 x2 of 2 x2 of 3. Then after that this particular x2 is coming up to this particular position, and it can be written like this. Then the total sequence is coming 0 1 2. Then again after that x2 is coming from this particular sequence, and it is represented over here, then 2 of 3, then 0 1 is coming like this. Then x2 of 1 again it is coming, and it is going to have the position like this. Then x0 1 2 3 it is written, and finally the total output of the sequence is evaluated from this particular section. Now you have the sequence of x2 and you have the sequence of x1. Just put down the value over here, multiply it, and finally you got this particular result. So this is the way how you are going to obtain the circular convolution using matrices. Next, we have evaluated all the method with one example. First is graphical method, then tabular method, then matrix method we have evaluated. You can be asked any method, or if it has been asked to do the circular convolution and two equations are been given, two sequence are been given, and then on it's totally up to you. Now in this case, suppose that I'm going to have another question. You are asked to find it out. One is equation is given x1n, another equation is given in h of n. Now we have to write down the total formula for circular convolution, that is yn, that is xn multiplied by h of n, circular convolution of hn, the total formula. We are going to do this by tabular method. So first we have to write down the total table. This is the position value which I have written over here. Then after that x of n is been replaced by x of minus m, this particular line is been written. Then h of n again it has been written by h of minus n. Then on it is having the two number of samples, so you are going to obtain two samples. So starting from for 0, and another samples you are going to obtain, that is 1. So 0, that means we have to flip the total sequence, and if the sequence is looking like this. For 1, it is going to be shifted from left side to right side like in this manner. So in this way you are going to obtain the total samples like this. And after that you are using this famous formula for circular convolution, y of n, the total sequence one by one you are going to evaluate, that is for n equal to 0, and for n equal to 1 you are going to evaluate. Use that total formula, write down the total sequence like in this manner, put down the value for h is equal to 0, h is equal to 0, x of 1, h of 1, and evaluate the result for n is equal to 0, this thing 10 1.0. And for n equal to 1, again you have to put down the total sequence, write down the total formula like in this manner, x is equal to 0, x is equal to 1, just like your previous case, these two case. then put the corresponding value and evaluate the result. This is the result. Now finally you have the result of 1 and 1.25. You just put down the value over here, and finally this will be the final result of your total sequence which you have obtained over here. And also don't forget to mark this particular arrowhead. This is indication of, this is the position value of 0. So that is the point you have to evaluate it. Next, take another example. Now this time we are going to have a different situation. We are going to do the circular convolution using linear convolution. So for that we are having one question. Now suppose that the question is been given, the input xn and impulse sequence hn of a LTI system is given by, this is the sequence. First sequence is given x of n, second sequence is been given h of n. So x of n, that is minus 1 comma 1 comma 2 comma minus 2. Another sequence is been given, that is 0.5 comma 1 comma minus 1 comma 2 comma 0.5. Now from this case the x of n is starting at the position value of 0, but for this case starting position value is not 0, that is minus 1, then it is 0, then after that 1 2 3, like in this manner it is coming. So if I'm going to do the circular convolution using linear convolution, so first you have to evaluate x of n. So x of n is having 4 number of samples, h of n is having 5 number of samples. So 4 plus 5 minus of 1, so that is coming total number of 8 number of samples you are going to evaluate. So this is the case which you have written over here. After that it is starting, x of n is starting from 0 and it is starting from minus 1. So that's why 0 plus minus 1, this particular line is been written, 0 plus minus 1, that is minus 1. From minus 1 it has been started. So that means 8 number of samples you are going to evaluate, but its starting position, that is from minus 1. Now to do this using circular convolution, you have to equate as per this position value, you have to equate both the terms. If it is having 8 number of samples, so total number of samples 8, you have to equate. So for doing this, so you can see here minus 1 is there for second sequence, but there is no minus term, so you have to add one extra 0 for this case, then minus 1, then 1, then 2, then minus 2, then 0 0 0 you have to add. So that means 1 2 3 4 5 6 7 8. So here you are having total number of samples, that is 8. Now for this case it is starting from minus 1, so that was 1 2 3 4 5 6 7 8. Now this 3 extra term is been added, so here also you are having the total number of samples, that is 8. So 8 and 8, that you have to equate both the terms. After that we are going to solve this using a tabular method. So for that you have to write down the total thing using the table. So first m indicates the position value, so from minus 7 to plus 7 its position value it has been written. Then two samples we are given, so first one x n and then on hm. So x of m it is written like this in terms of x of m, h of m should be written like this, h of minus m, so it should be written like this. After that you have to flip it, the total sequence as per the circular convolution, that is flipped sequence is been written over here. Then starting value is from minus 1, we are going to evaluate 8 number of samples, so that means 0 minus 1 1 2 3 4 5 6 7 8. So from here to here total 8 number of samples we are going to evaluate from this to this. So for minus 1 you have to flip and you have to make this particular line over here as per the circular convolution for minus 1, then from 0, then 1, then 2, then 3, then 4, 5 and also 6. So these samples you are going to evaluate each and every time when it is 1, so it is shifted from left side to right side. You can see here each time it is going to be shifted from left side to right side, like all this manner it is going to be shifted. Now after that you are going to use this particular famous formula for the circular convolution, use this particular formula, then one by one as per the samples, for n equal to minus 1, for n equal to 0 1 2 3 4 5 and also 6, use this formula, write down the position value for xm, there is no changes, so you can see here. But once you are going to use h of m, its position value is going rapidly changing. For each and every case you are having different result. You can see after multiplication and addition you are getting this type of resulted over here, and finally you jotted down all the 8 samples and you got this total final result. So this is the way of how to do circular convolution using linear convolution. So this is the way you are going to do it. So in this way you can do the circular convolution, and these are the references for your future purpose. Up to this I'm concluding today's session, and thank you. Thanks.